Homework challenges, we all love them, and that's why we're going to check out the answers and the reasoning behind the answers, correct answers, for the homework challenges I gave you at the end of lecture 4. So here we go. This is the first one, and here we need to check whether the sentences listed below are logically equivalent to the one depicted at the top. And I can spoil the surprise right now and tell you that indeed the first one is logically equivalent to the one depicted below. And because, you know, yeah, right, we need to focus on logical relations, right? And focusing on the logical relationship means that we are on the lookout for that if operator, and that if operator is followed by we live on a deserted island in the original sentence, and it is also followed by we live on a deserted island in this new sentence, and the then part is also present in a similar logical manner in that sentence as well. So even though the if part has been moved to the back of the sentence, the if part still contains the same being we live on a deserted island. So that one is logically equivalent. The second one is logically equivalent as well, because perhaps you recognize that you can symbolize the first sentence as if P then Q, so that's similar to saying if not Q then not P, because of that trick of contraposition I explained in the other video. But perhaps you could also check it out in a more intuitive way, right? So you could use those parachute method I mentioned in the lecture. So you can basically draw a map of P and Q, of living on a deserted island and drinking milk from a coconut, by drawing living on a deserted island as a smaller circle lying within that bigger circle of drinking milk from a coconut. And then we can imagine us jumping out of a plane and us landing somewhere. And then we've landed somewhere, and we ask somebody, where did we land? And they say, well, you've landed in the dark blue area. I'm sorry, guy, but yeah, there's no drinking from milk from coconuts here, right? Then you know for certain that you won't be living on a deserted island as well, right? Because if you're not in the area of drinking milk from a coconut, it should be obvious that you're not on a deserted island if we use this map. All right, let's look at the third statement, which is not logically equivalent to the sentence listed above because a different logical operator is used, right? So it still says, still uses living on a deserted island as well as drinking milk from a coconut, but it says we either do one or the other, which isn't true in an inclusive sense as well, nor is it in an exclusive sense of using or. It should be obvious to you that or expresses something else. Right, so if you're saying I'm a man or I'm a woman, that's something else from saying if I'm a man, I'm a woman, right? So that's a different logical expression. Check it out in the book as well. The fourth one is indeed logical equivalent, because it does use the or operator, but it denies one part of the if then statement. And you can also use the map again to check it out. So we've drawn the same situation on the parachute map, and we've jumped out of a plane. And what this statement basically says is that we're either in the light blue area or we're outside of the red area, right? So if I'm not drinking milk from a coconut, I'm also not on a deserted island, which is basically the same again as the previous example we checked out with the parachute method. All right, hope that makes it more intuitive. If not, you can still check out a more detailed explanation of logical equivalence in the separate video I made for that topic. All right, let's go to the second example. The question was, is this a valid argument or not? And perhaps you were tempted to think that, yes, indeed, it's valid. And the reason why you thought it was valid because you made this step. So you put it in symbols. If Constantius was a Christian, then he was not adequately described in the history books. Constantius being Christian is the P part of the conditional statement, and not being adequately described in the history book is the Q part of the statement, if P then Q. And then you would move to the second one, the second premise, and that says there's no evidence that Constantius was not a Christian. You might have interpreted that as a confirmation of P, so of a confirmation of Constantius being a Christian. But strictly speaking, you cannot do that. Saying there's an absence of evidence isn't the same as saying there's evidence of absence, right? So putting it differently, saying that you can't say that something is not the case is not the same as saying that it is the case. Those are two different types of statements. So you can't translate that second premise to a confirmation of the P part of if P then Q. If you could have done that, of course, this would be a logical, deductively logical argument, right? If P then Q, P therefore Q, that checks out. But we can't translate that second premise to being a confirmation of the first part of the first premise. Another way of making that more intuitive, I hope these silly examples, the parachutes and now a counterexample, make it more intuitive. If not, just focus on the essence and skip this counterexample. So if somebody comes up to you and says, nowhere in historical documents it is proved that aliens weren't at the first Thanksgiving, and therefore says it's necessarily the case that the first Thanksgiving was visited by aliens, you wouldn't be inclined to agree with that person, right? Because of course it's not true that if something cannot be proved, the opposite is true, which is implicit in the argument as just given. If we do say that yes, P2 is true, that would lead to very silly conclusions, that we're able to say that aliens would have visited that historical Thanksgiving dinner because we can't prove that they weren't there. And the same applies to the Constantius example. The fact that we can't prove that he's not something doesn't mean that he was that thing. All right, so let's move on to the third homework challenge, which is still checking whether an argument is valid. In this case, it's a bit challenging, right? Because, well, it has a different form than the if P then Q statement. There's the multiple premises which are intertwined, if you will. So one way of figuring out, or the best way of figuring out that this argument is indeed valid, is the following. Because you can assume the conclusion to be not true and check out what happens. So if we move I've moved the argument to the left here, and then we'll be applying all the parts, but we start with the conclusion. So let's just assume that the conclusion is not true. So the conclusion that Roland is not smart is not true. That means that I am smart. If I am smart, if Roland is smart, that implies that Sharon isn't smart, right? If we apply that third premise. I'm smart, that means Sharon is not smart. Then we move to the second premise. That just means that I am an SSR teacher. We add that. And then we get to the first premise, which says that if a SSR teacher is smart, and again, we're assuming that I am smart and I am an SSR teacher. So indeed, a SSR teacher is smart. That must mean that Sharon is smart. But we also assumed in premise 3 that Sharon is not so smart. So that's a contradiction, right? Assuming that the conclusion is false leads to a contradiction between premise 1 and premise 3. Which is another way of saying that the only way for all premises to be true is for the conclusion to be true as well. Because it being false would lead to a contradiction between premise 1 and premise 3. All right, let's move to the fourth example, which is also a challenge. That's why they're homework challenges, right? But for a different reason. This is basically a chain argument, and most people that came up with this example, it was a tutorial group 2 years ago that came up with this example, were confused by it because it intuitively makes sense that the conclusion would be true, right? So we're hindered by a case of belief bias, as we talked about it in the first lecture, but because indeed this argument is not valid. One way of showing why it's not valid is by, well, first putting this in symbols, right? So recognizing that this is a certain type of chain argument. What this is saying that if it rains, it is cloudy, you could symbolize that if P then Q. Then if it's not cloudy, so cloudy we called Q, so we need to be consistent. So we say if not Q, then the sun is shining. So that's a different term. So we can label that with a different symbol. We call it y. So we get if P, then Q. If not Q, then y. And the conclusion is if the sun is shining, so that's y, the sun shining we called y, then it's not raining. So we need to go back to that first symbol we used for rain, which is P, and deny that. So if y, then not P. So we get if P, then Q. If not Q, then y. If y, then not P. All right. Does this check out? Is the conclusion necessarily true if the premises are true? Well, not really. And one way to see that is to offer conditional proof. Conditional proof is basically just assuming that the first part of the conditional premise in the conclusion is true. So we're assuming that y is true. That gives us a different argument. The first two premises are still the same. So if P, then Q. If not Q, then y. And we're just assuming that y is true. Does that have to mean that P is not the case? So that P is false? Not necessarily, because this should make it explicit that if you assume that y is true, that doesn't necessarily mean that not Q is true, right? Because then we would be confirming the consequent of a conditional, which has no logical implications for the truth or falsity of the antecedent. If that's still a bit abstract, we could also use one of the tools I gave you in the fourth lecture. So we draw out all possibilities, and it's become a somewhat larger tree diagram, but we can draw out all possibilities. So we have three categories, basically, there being sun or not, there being clouds or not, and there being rain or not. And then it can be related in different constellations. So there can be sun, no clouds and rain, rain, clouds, no sun, etc., etc. if we apply no restrictions, so if there's no rules that apply. If we apply that first premise, that introduces some rules, right? That excludes certain possibilities. So if it's raining, then it's cloudy, excludes all cases where it's raining and it's not cloudy. So we can scratch that no clouds and the sun related to that scenario. So we can deduce that scenario from all possibilities. Similarly, if we apply the second proposition, so if it's not cloudy, then no sun, we know for sure that this situation is impossible. So the combination of no clouds and no sun is impossible. So no clouds means it's sunny, so we can take away that other scenario. And this is the remaining. These are the remaining possibilities if we apply both the first and the second premise. So these are still all the remaining possibilities. And if we then ask ourselves, does it necessarily mean that if it's sunny, it will not be raining? No, not necessarily, right? Because there's three cases still possible of it being sunny. And indeed, in two of those three cases, it will not be raining. But in one case, it's still possible that it rained. And we don't know for sure which of these three situations apply, right? So it isn't necessarily the case that it's not raining if it's sunny, given the first two premises. Which is, yeah, it's confusing, right? Because it doesn't accord with what you believe to be true about the world. But again, we're not checking whether your beliefs about the world check out. We're checking whether the first two premises necessarily mean that the conclusion is true. And we've just seen that that's not the case. Because indeed, as you can see here, if we consistently apply all rules, exclude possibilities that are excluded by the first and the second premise, then we cannot conclude with certainty that if it's sunny, it has to be not raining. Because you can see that this scenario is still not excluded. All right. I hope that helps with your studying of the material in chapter 3. It was an extra challenge, so don't be too bummed out if you got these wrong in the first instance. They're challenges for a reason, so they're particularly difficult examples of the material we've covered this week.